All right, so you want to try explicit lights then? We could start with point lights, just a list. And then I guess we'd need something, or we could do area lights.
Yeah, we could do something, yeah, and then generate random points on the, yeah, because that's the idea.
Yeah,
Right? Generate random.
maybe like a canal box like shape.
Or you know, actually last week we had the idea of doing emissive materials. Maybe instead of explicit lights, we could do that.
Emissive?
Yeah,
Yeah. Then we can extend that to explicit light later. Yeah.
Cool.
So let's.
So it'd just be a material property, I guess, or a new material index.
Yeah, it's new kind of material.
Yeah, so we have to add another material.
I guess, well, but yeah, I think it's new kind of material probably is the best way to do this.
Or we had something with type 2, I guess, or something like that, and then we'll check for that in the switch statement. That, yeah, cool. We could do some defines to make these simpler to reference if we want to do, like, define 0 as
Yeah.
roughness or not roughness, whatever it is. It's diffuse material or specular, I forget.
I think you have two specular. So specular is diffuse is 0, specular is 1.
Well, I think one of
Other
them
way
was,
around.
yeah.
So 0 was specular and 1 was diffuse.
Yeah, cool. I think we had started on another one that was mixing the two behaviors, but I don't know how far we got on that. Oh, comma at the end of line 33.
Wait, what is diffuse? Okay, yeah. Specular. Maybe let's add another. Or do you want to code this part first?
I mean, shouldn't that just like return the color and nothing else? Or what?
Mm-hmm.
Should it return?
We can try it.
Just like,
I feel like this logic is wrong. Let me,
probably.
Well, the other ones do color star times.
I mean, that's, yeah, it's,
Although, yeah,
that's
I
because
guess
we're
what's stop?
accumulating.
Yeah, yeah, they're not reflective. Okay.
yeah.
Yeah, but yeah, this does look like this, which is a good sign.
Do we have anything using?
Let's,
Yeah, we need something with that material.
Well, those are
Oh.
material indexes, so we need to just, you need to like
Okay.
specify 4 or something, or 3.
Yeah, we want to
Oh.
index into the material list.
wait, so but
No,
the
those,
second one is already emissive.
the sphere
looks very-
struct doesn't, it contains a material index as the
Hmm.
third parameter, not
Yeah.
the material type.
Yeah, line 29 through 34, that we're indexing.
Oh, I see. So add another thing. Maybe we can do 2 mapping next because we kind of have some lighting effect.
Yeah.
Yeah, there's a lot of good drop-in solutions for that.
Yeah.
Yeah. Come at the end.
That's stupid. That's
I
like
know.
JSON. Where's the?
Do we have
This is
a
in-
Oh, we're behind it. Yeah.
Still, where is it? Doesn't show anything.
Are you inside of it? Because it's very close to the center.
should be above the surface?
That's true. Oh, there we go.
Cool.
Yeah, change that. Yeah, there we go.
Is it light too weak?
Yeah, maybe. Yeah, multiply that by something.
You could also make the, just for testing, you could make the
Yeah,
skybox.
that's definitely not right because the light does not contribute to anything.
Right. Yeah.
Could you also make the skybox black? So it's easier to tell what the contribution of the light is.
Yeah, this skybox is too bright.
Well, oh, there's a tiny little sliver of blue, and there's probably some glitch causing the pink at the bottom.
Interesting.
It is.
Yeah.
So what's going on here?
Should we be adding instead of multiplying the color?
Maybe.
Because like wire color is like an input. Well,
color is the amount of like reflection you got from all the other surfaces combined.
oh yeah, because we're iterating. We're not.
You're going in backwards order, or from the eye to the light.
Actually, no, we're cursing, so
Yeah,
it should be
have
one.
really strong color here.
Move it
But
a little bit
still-
farther forward towards the camera, so it's not just bouncing off the back.
Yeah, because I think it's like very far behind. No, it's
Yeah,
No,
No, it's not.
that'll be the Z axis. That'll be, or wait, where's Z up?
yeah,
Right?
Yeah,
it's
Z is
just
the into the
it's
scene,
just
right?
like really. Oh, maybe because our specular material is too good, but the diffuse should do the work, right?
I thought the ground was diffuse. The bottom sphere. Hmm.
Yeah, I
Well,
think it's,
so
isn't it?
so does diffuse, like a diffuse, is it doing some reflection here somehow?
The diffuse should be. It's like picking
Yeah,
a
the
random ray
diffuse should
direction.
be.
Oh, okay.
What is the ground material?
Right. So that's why you're getting
The
that's why you're getting the
third-
noise on the
third
yeah,
bottom,
the
right?
ground is diffuse.
Can you increase the roughness of the ground material? It's at 0.5 right now. It's just like set to 1, I guess. Or yeah, well, that I think we're hitting the fact that the light's very small, and so only a small number of rays are incidentally hitting the sphere.
But you did.
But yeah, but it still shouldn't like that, and you can see nothing get accumulated over time. If that's the case, then it should like accumulate over time. But
Well, it
that
does. There
didn't
are
happen.
some, like when you move the camera, you do actually see something for a second, right?
Yeah, something is accumulating, but still, like most part of the is
think-
dark. Which is
I feel like we're multiplying by 0 rather than adding 0.
yeah, you can see something is.
Oh, is it now stable?
Or you made it bigger. Okay.
Something like
Oh. Was it just too small and so very few rays were hitting it?
Yeah.
Still, it doesn't looks. This number is really big.
I'm concerned about the pink area underneath the pink sphere.
Yeah. That's
If I
wrong.
have thousand, it's still like that. It's
Can we do return matte color instead of return color times matte color?
Yeah, maybe.
Or color plus matte dot color?
Yeah, what if we?
And everything's just going to be white, right?
Apparently not.
yeah.
Maybe the color was, you know what? Color was 1 whenever we sample this. So that color variable did nothing for us. So it was already doing what I suggested.
Where
because-
are we?
But color should change.
No, well, what I'm saying is
Oh look.
when you cast a ray, the material is same every time, right? Or not? Oh, maybe I'm misreading this.
Yeah, materials color.
Yeah.
They are definitely not. We can use something like more, not that extreme, but still.
Yeah, something non-zero. Probably helps.
Something is definitely wrong.
Yeah, I want to look at how we did the looping.
I can't see anything now.
Neither can I. Oh.
And
There's a weird, almost kind of like a weird halo at the bottom.
yeah,
Like it's casting a shadow in its own light.
So can you go back to the?
so yeah, something's wrong in this part.
I can't see the whole function. What does it do after that? Else it doesn't do anything, right? At the very bottom on line
it turns-
145. Yeah. Okay.
return color. So this
How about
is,
you? How about just return
Ah.
color instead of, and just to see what the color value was.
wait, why we have break here? Oh, this
that's
break
for the
is
spectator
switch.
case.
This is a break of the switch. But here we shouldn't continue the loop anymore.
No.
Can you just return color there on 137 just to see what its value, see if it is always white? So now what is it doing?
Wait, I have a feeling we like this line
It's never getting
color
hit.
and matte colors. We
So
don't
just
even
return.
have any effect.
Well, actually just return some specific value like vect3 and see if it actually ever gets there.
Yeah,
Like
I
green.
feel like we haven't even hit this line for
Yeah.
some reason.
Yeah.
Mhm.
Are you doing enough? Are you actually checking all of the spheres in the raycast? Maybe you're only checking the first 3 or something.
It's worth checking. Oh, it's spheres that length, so it's.
Oh yeah, but I mean, you are seeing a white sphere there, so it is actually testing it.
It's looking at the array length to
Yeah.
iterate through. So
Yes, so something with materials. Well, materials hit dot material index. This part looks right. Yeah. So our material is correctly emissive, but then why? Then why we never hit that line?
if we add to the color, we do something like, well, no, it doesn't.
So I mean, is it a problem with the saturation because it's 100 instead of 1 for the color?
Yeah, are we?
Because if you do that, right, like, oh, I guess all of the mirror values are actually pretty big. So it's
Does
either 1 or 0.
is hit being updated correctly? Is I guess cast array should be writing to hit as an output. So I don't know.
Yeah.
So what was the values of hit that were being used later?
I mean, position normal.
Right. Yeah, it should work.
Material index.
So what I mean, so when you get out of this loop, what is actually used of hit, right?
It is a local here, so it's just new value each new iteration.
Yeah, hit is local to the loop there. Yeah.
Yeah, why we never hit this branch?
I feel like we are.
Well, but it should be red.
Then, yeah.
Oh.
But it's weird, like it's actually returning. You do actually see the emissive sphere as a white thing, right? With no shading.
So wait. The returned color, is the returned color being ignored? And that's why we're not seeing anything?
So yeah, it does seem like it's instead of like the switch statement isn't working, it's going to So, oh, here's an easy way to fix it. Okay, so in each branch, have it return a different color so that we can see which branch it's actually doing. Like,
Yeah, just for debugging the materials. Yeah, that's a good idea.
still white.
So
So for some reason, we didn't hit into this switch.
so trace ray gets called like once per pixel, right?
Yeah.
Okay.
I wonder if we need to do, well, shit. Yeah.
Or is like the semantic of GIS cells
So
different?
go down a little bit. I mean, so the color starts at 1, right?
Yeah.
So is there any early exit from this thing? No. Oh, can you do like a case default or something? Like after emissive to see if it's always falling through for some reason?
I'm confused how it's getting the material colors because it doesn't seem like that should be possible the way we have it now.
Yeah, so there's some case where it's always going.
I have a feeling this switch statement messed up for some reason.
So what? Look at mat.type. What is? I mean, is that
It's blue.
in the definition of material? Maybe it's a compiler bug or something.
Yeah, sounds likely. I feel like it's a compiler bug of we just use switch statement in a weird fashion. They didn't. Let's do this.
Can you save the shader and paste the link to it in chat so other people can help debug? Oh, it's also private, by the way. All right, thanks. Yeah, it looks exactly the same on my machine. I'm just gonna try some different things now.
It's interesting. It's all green on my machine.
Yeah, but you had,
Oh, so I feel like it's a compiler bug then.
well, JB had issues with
Yeah, it
running
was
it
all
last
black.
week.
The starting point was all black for me. So
I have the same as Leslie.
Yeah, I get the Leslie's version. Okay. So maybe it has to do with defines or something.
Wait, but
Oh,
we shouldn't ever
okay.
get it.
No, look at the background ray. Because if wait, no shit, never mind. Ignore me. It returns perfectly black, so it will just multiply to 0 if you ever hit. But that's what we wanted, so never mind that.
Let's comment out those lines again.
okay, then where is it getting white then? Because that doesn't seem.
Yeah, when we comment out this line, we shouldn't get white.
I'm not sure where that's coming from because it's when we hit the emissive material, it should be returning red.
Cat parentheses around cases? Seriously?
Maybe.
Could try
Sure.
if statement.
I removed parentheses around the cases. Try if statement.
Cast ray returns true if it hits something, right?
Yeah.
It's like a compiler bug.
Okay, and it should
I
update.
revert the code back to the original and it's showing something else. So it's keeping the state of whatever I had changed instead of reverting back to the normal.
Okay. Wait a second. No, that's not anything. No. I'm wondering about the ray sphere intersection, how it's setting the material index, if that's maybe anything, is it? It looks right.
No, that's definitely some bug. Because this looks much as expected.
Yeah.
It should be.
Can you save that? So.
Yeah, we should.
Yeah, because I use a really bright color and without two
Yeah.
mapping.
So the switch statement is to blame?
Yeah.
Oh my god.
Interesting.
Yeah, I have a feeling either JSL semantic of switch is different from C, which
weird bug.
it's a compiler bug. That's so stupid.
I know the Xbox compiler throws different warnings about like default case stuff than, than your standard GLSL.
Switch case considered harmful in JSL.
It's actually less code too if you do it this way.
Yeah, also because we don't need to do all those break stuff.
Oh. I think maybe the bug is because we had a return statement in the switch cases.
Which messes up.
Is that illegal or something?
It should
Possibly.
be legal in C or C++, but probably the compiler, JSL compiler just couldn't handle that.
It's too powerful.
Yeah, that's it. You just we just need to set color, the color, that variable directly, and then set like I to and then break like I equals 20. So we need to break out of the for loop, and then it will return the color rather than color times background. And now I'm getting a nice red sphere. So we can use if statements just fine. I don't want to redo
So
that.
is
But that's the bug, having a return statement in the switch.
is this two mapping?
Oh yeah, I just set the tone mapping curve. We could use if you want.
Oh, very nice and easy.
Should
one.
be after final gathering. Yeah, we don't want to map into the buffer. It should be
Right.
after final gathering.
Should be after the averaging. Yeah, that's right. Oh, that's good.
What the?
Well, we tried.
Oh, is it? Is it because when you write out frag color, that goes to the screen and that goes into the history? Is that what's happening?
Oh,
it should be in buffer B.
it is. We're still right into the buffer.
Oh
yeah,
yeah.
Should be in
yeah.
buffer
Should
B.
go
So
Or
so it
image.
shouldn't be in here at all.
Should be an image, I think.
Yeah.
Also gamma correction, I guess. It'd be pretty
Yeah.
easy to add. I like watching all the color just fade away.
Yeah.
The world's saddest path tracer. Oh, fright color, yeah.
Yeah. And let's use some. Let's restore the. Some reasonable value.
Now on the diffuse materials, we have a scale factor that that's like a real-time approximation kind of diffuse. I'm wondering if that's right. I just given the way that highlight is on the ground and stuff. I'm wondering if that's maybe coming from that.
Oh yeah, that's really weird disk on the ground. Something is up with it.
It's probably our diffuse sampling being whack, and it's an artifact of how we do how we choose our random number, if I had to guess.
It's possible.
Wait, you're not supposed to do it this way. What is RNG state?
It's global, but it's not initialized. Well, no, we initialize it in main.
That's just yeah, definitely shouldn't be the way to do stuff.
We didn't know how to do it, so that's what we figured out.
Oh yeah, we gotta. Yeah.
Oh yeah, we create the. Do we add the parameter? And then yeah, we didn't pass in RNG state into the function.
What's
Oh yeah, we gotta just add a declaration.
Yeah, vec 3, vec in whatever.
UN, I think. Unsigned.
Yeah.
yeah.
All right.
We still have that disk though.
Yeah, I wanted to look at the diffuse case on the materials stuff because I'm wondering about that.
Oh, but also we are not updating the RNG state. Yeah, we're always generating the exactly same random number. Oh, is it uniform float is
Uniform.
in out?
It's in out, yeah. It's in.
Does GLCL guarantee the evaluation order?
Probably not.
Yeah. Because C is a really good language. Everyone should just use whatever C have.
Oh man.
Random directions, only positive directions. No, it's that times 2 minus 1 is going to give us something centered about 0, I think.
Yeah. Why? Wait, what is this random direction? Why? How do you do this stuff? It's not supposed to do it this way.
We just kind of like.
We just did some hack.
Oh, maybe that's why the thing on the ground looks all messed up.
It should be
Yeah.
it should be latitude and longitude, right? And use cosine to figure out and sine.
It's gonna be
Yeah, that's what we should. That's how to sample in a sphere. That kind of thing.
Yeah, you're right, because it's going to be biased because it's in the -1 to 1 range on each axis. It's going to
I
be
can't
biased towards the
I
corners.
can't remember exactly code for that, but the basic idea is we need to sample like that and then normalize.
Well, we need the thing to generate the point in the unit sphere there, I think.
Yeah, it's in the hemisphere.
I recall last time, the intention with that random direction function was to generate a point in a sphere and then like offset it or something.
Yeah. Like if it's
But
offset, it's going to be in the hemisphere always.
But if you think about it, if you're uniform on each axis and then you normalize it, it's going to have a bias towards sort of the corners of that cube because there's more.
Yeah.
Yeah, more generated in that part of the range.
Yeah. So what we did here, yeah, it should be normal plus random in unit sphere, but this is just not random in unit sphere. Like
Yeah, so you have to do latitude and longitude, and the latitude or the latitude
yeah,
is
let's just
uniform, but
quickly
then
look up.
Here's a
There should be one we put in recently.
I shared one from the casual Shadertoy path tracing article. We'll need to change names, but I think...
God, I'm sorry. You're looking at Discord right now, and I'm like, oh, I'm gonna go click my wait.
Go to
That
scroll
doesn't
on.
work. Because it's your screen cap of your Discord. Gosh darn it.
Yeah, I've done that more than once this evening, trying to scroll on pages that weren't mine.
I do that all the time. You know what would be
What
chaos?
is our random code?
Yeah, never mind.
Uniform float one. Okay.
RNG state. Yeah. So. Then we need pi to find. We do inverse sine of what is it? 1 or inverse cosine of 1. Inverse cosine of 0.
Probably JSL wants let me to do that though.
Times 2.0 or does it care?
But the point is,
It'll get it from the other flow constant.
the point is JSL can't do this kind of thing for constant. Still don't look right.
Well, it doesn't. I think that was part of the problem. We don't see the cross shape on it anymore, so that's positive.
Yeah, normal plus random and yeah, we should probably call this is random in sphere or on sphere.
What if we do hit that normal times like 1.001 or something like that? Make sure it's not going to self-intersect.
We already did plus here, so
well, you kind of need to rotate right by the normal.
wait.
So like the one axis is long, like if you have a hemisphere, right, and you have an arrow pointing up, in the hemisphere, then that has to be along the normal. And then oh, so how can you rotate to a normal?
We didn't hit dot normal. That should already.
Because it's going to be unit length and like, well, I don't know how much, you won't hit the cases very often, but if it's pointing straight down, it'll maybe self-intersect. I don't know.
Yeah, this is unit length wrong, right? This is 0 to 1.
Well, I think the XYZ are right as long as your normal points straight up along Z. But really you need to change the random direction has to be with respect to the normal.
That's.
Can we try to like visualize the random in-unit sphere and just like, I don't know.
Not sure how we visualize that.
Yeah, I don't know either how to visualize it. I'm just wondering if we're like shooting in the dark and I mean, it looks really cool, but that's
When you add them
not
all
very
up, it doesn't
helpful.
make much sense.
Yeah.
It'll start averaging to 0, yeah. If it's uniform. The one thing I was a little concerned about is 135. Could we try it without that multiplication? Just return or times equals mat.color and comment out the rest of the line.
Yeah.
Yeah, what is that?
It's trying to be like cosine fall off, Lambertian fall off or something. Kind of.
It's not helping. Well, never mind.
So basically you have to
sorry.
the random direction you're getting is pointing in the Z direction, right? Like the hemisphere is in the Z direction, right? The positive Z, if I look at your function correctly.
But also consider that it's plus the hit dot normal. So normal is going to be unit length.
Right. And so, but basically you actually want to rotate that hemisphere so that the top point in the hemisphere is pointing in the direction of the normal. Does that make sense?
Well, because we're taking this random in the unit sphere, and then that's going to be about like the tip of the unit normal. If you think about it that way.
Yeah, so we have intersection at here, let's say, and we have normal, and we are sampling point on this sphere. And this should already dealing with Lambertian fold for us also.
Can I draw a picture? I don't know how to draw. Just to show you what I mean, it's hard to say with words.
Sure. You can probably try the Zoom's annotate functionality. I don't know how that works though.
I don't know either.
Can you try it?
So I can't share what you're sharing, and I don't know where annotate is.
Okay.
Such a thing.
I have to sign in.
Annotate at the top of the screen is under like options or something.
Okay, so you guys can see this.
Yeah.
Yeah.
So like we're getting. Oh, sorry, I'm not very good at drawing. Let's see, with the mouse. All right, this is your hemisphere, right? Whatever, and this way is positive Z, right? That's what that random direction thing is producing, right? Does that make sense? Or
It makes sense to me.
okay, so the thing is like when we're going to actually put that on some surface, right? So like if it's on this point on the surface, it needs to be over here. And if it's on this point of the surface, it needs to be over here, right?
It doesn't matter. We don't sample this way. We are sampling a whole hemisphere, not a hemisphere.
This function is returning a random unit vector. it's not a random in a.
Oh, so it's a returning a random thing on a sphere. Okay, I thought it was hemisphere.
It should be
guys
on
are-
a sphere.
It should be
Yeah,
on a
that's
hemisphere,
why
right?
we add. That's why we added that normal to it, because
Well, let me send you where I got it from. Maybe.
So like, okay,
it's-
so like if it was a sphere, like say if we're over here and then you add the sphere to it, right? Then, I mean, really when you're doing diffuse, you only ever want to do stuff that's in this hemisphere, right? You don't want to do stuff that's going backwards.
yeah, but that's
I don't
if we
wanna-
add normal, this way should already be handled.
The sum of it is then normalized, so it's gonna be a displacement off of the surface.
Okay, I'll trust you that that's right. But then I think the distribution is going to be wrong, right?
Maybe.
It's kind of get
Yeah.
the same kind of artifacts, right? If you're smushing it down,
Yeah.
it's not going to be uniform. I mean, so really what you want to do is rotate by the normal. So,
Does
it's,
it matter?
Wait, I have a random in hemisphere function in my path tracer project. But also JB pasted one already, so
Also
Yeah,
share
everyone
screen,
has this.
Leslie.
Wait, what is this roughness time? Because if I remove that roughness times that
Can you
Render
share your
in-
screen?
Yeah, you're
Yeah.
not sharing your screen.
so if let's just say roughness is 1, then it looks okay.
You're still not sharing your screen if you thought you were.
We're not. Yeah.
Well,
There. There we
There we
go.
go. Oh, this is looking way better.
yeah, so I think maybe this logic is wrong.
Which would change.
Oh yeah, that's wrong. That should be somewhere else. I think we're trying to accentuate how random it is by the roughness, so it's closer in. And the idea is if you generate a smaller sphere, it would produce less random normals. But I have no basis in that actually
Oh,
being
No,
correct.
you're right. You're right, because that's going to be shit. Okay, we should use that as a lerp between specular and diffuse behavior. I think more than we should to scale that.
Yeah.
So, I mean, it should actually be a parameter to the random direction generator, right? It kind of does an exponential so that you get more rays that are closer to the z-axis.
Well, think about it. Okay, just if you generate your perfect reflected ray, and then you generate one of these rays, and then you kind of lerp between those with the roughness. Would that make sense?
it would make sense to maybe not to like lerp between the perfect reflection by the roughness. So like we get that reflect ray direction hit normal, and use that as the second parameter for the lerp, where the first parameter is our random in unit sphere. And then we control how much we lerp between them based on our hit material dot roughness.
Probably we can just
Not
do some research on how to do this, and probably we can
Mhm.
then do that later. We make fair amount of progress today. The
Yeah.
bug is fixed. Yeah.
it's called we
There's a-
fixed all the things we broke last week.
We've got a new bug in the reflection on the specular sphere, but such is life. Because there's a cut out of it, like it's behind the other sphere. It's like a
Yeah,
Wait,
that
Nick,
looks wrong. Yeah. So wait,
oh my god.
I don't know if it's being used anywhere, but yeah.
Okay, good one.
That's even worse than that Indiana Pi deal. That's like 3.2, right? Let's restore the background. Maybe use this instead.
Yeah, we can try with the texture, maybe. Yeah.
Yeah, the
Oh, very
random
cool, very
number.
cool.
That's looking pretty good. I gotta be
Yeah.
honest.
Yeah.
We've made some serious improvements.
Yeah, and maybe we can do some research on how to do BRDF, how to extend, like, then we can implement that next week.
Cool.
Yeah. Let's stop it.
Yep.
Stop the recording. And